Hello guys, my name is Lazar and today we're going to be doing a LeetCode problem. This problem is called climbing stairs. You're climbing a staircase, it takes n steps to reach the top. Each time you can climb either one or two steps. In how many distinct ways can you climb to the top? So they just wanted us to figure out how many ways we can climb from starting step 1 all the way to n. So for example, if you only have two steps, we can do this in two ways. Either take one step and then followed by another step of size 1, or do a step of size 2. If there's 3, we can do 3 steps of size 1, 1 step of size 1, and then another step of size 2, or the exact same thing as this one, but repeated, where a step of size 2 is first, followed by a step of size 1. So what this problem is really asking us is, let's say we have a function f of x. We want to compute how many ways we can climb the stairs, and this f of x is equal directly to f of x minus 2 plus f of x minus 1. How many ways we can climb the stairs if there was two less stair two less steps plus the amount of ways we can climb it if there was one less step. Now we can go ahead and call this part right here B, and then this one right here A. And we notice that if we compute the next step, which is f of x plus 1, is going to be equal to f of x minus 1 plus f of x. Now this is still respectively b and this is a, but they're different b's and a's. This b right here we can call b of x minus 1 and a of x minus 1. Then over here we can call this b of x and then a of x. Now notice how a of x is equal to f of x. So a of x is equal to f of x, which is equal to b of x minus 1 plus a of x minus 1. From this information, we can just compute that any formula for a, let's say we have a of x plus 1, is going to be equal to b plus a, b of x plus a of x. Now, it's be a pretty similar fashion for b. Notice how this b of x is the previous a of x minus 1. That tells us that b of x is equal to a of x minus 1. So while well, I should put it in this same term as this one, b of x plus 1 is equal to a of x. This tells us that while a is being updated, b is kind of lagging behind by 1. Now, this information is all we really need. We can see that we can represent these values or whatever these variables are equal to by using two pointers or using two variables in our code, and making sure that we follow these equations. So this problem is actually that simple, so we can actually dive right into right now. Now the first thing we want to do is take care of a simple test case where if n is less than 3, let's just return n. Because if n is equal to 2, the answer is 2. And if n is equal to 1, the answer is n, which is 1. So if n is equal to 1, return n, which is 1. And if n is equal to 2, return n, which is 2. And those two are the correct answer. Else, let's create that a and b. Initially, a is set to 2, and b is set to 1. Because now we're taking care of the case where n is equal to 3. And we can go back here. That's saying that f of 3 is equal to f of x minus 2, which is just 1, plus f of x minus 1, which is just 2. And these cases we instantly know, where this right here is b of 2, and this is a of 2. When x is 2, we know the answer is 2, therefore a of 2 is 2. And b of 2, when x is 1, we know the answer is 1. So that's why a is equal to 2 and b is equal to 1. Now for I in range of 3, and since we want to include the n, we want to do n plus 1. If we just have n here, this would exclude n. So let's do n plus 1. And now let's save the last a. Let's make this equal to a. And a is now going to be a plus b, and b is going to be equal to the last a. Once again, we're following this formula right here. And finally, what we want to do is just return a. So now let's run this code, see if it works. It does, and before I submit it, let's just change it to be a plus equal b. Because since we're programming, we can simply do it just like that. And now let's submit. And it gets accepted perfect. So hopefully you guys understand that we're using dynamic programming for this question, where we're solving first smaller sub-problems to solve the main big problem. And one way we can handle these dynamic programming questions is by finding the recurrence relation, which is exactly what we did right here. And we were able to rearrange it in a way where we were able to boil it down to just 2 variables that we can represent in our code by creating variables for each of them respectively, and then updating them by following this formula. So hopefully this question was able to help you guys. If it did, please leave a like and consider subscribing. But other than that, thank you for watching.